from Singapore, and also today the day of the speaker, Dr. A. Sudhahar from Coimbatore. I'm very happy to welcome all of you for this 46th series of lecture going on as a part of the upskilling program for construction management and engineering economics. We started offline, online. There's a blended mode, or you can say hybrid mode. This is we targeted for the engineers, Nirmiti Kendra engineers, and also all other budding engineers and civil engineers. And even the online classes, they're given a very good response from many construction management trainee students and also the postgraduate students. I'm very happy to welcome all of you. And actually, these are defects in construction as the topic has been finalized as a part of this master's training program, because we all know that in the case of the rehabilitation, retrofitting of structures, there are three reasons three reasons are involved. One is design errors, construction errors, and material errors. Today, the speaker of the day, Dr. A. Sudhahar, CEO of the Dimensions from Coimbatore, he is going to share his experience on what are the various defects in construction going to occur if you are not taking care. Because I request all the Nirmiti Kendra engineers and also welcome all the engineers, project directors for this program. And he is going to share his experience, what are the mistakes generally the contractors or builders or any supervisors will make mistake. If you take care of all these things, we can overcome all these defects, then life of the building will improve. The quality, what is the lifespan designed for the structure to perform. Otherwise, we have to go for repairs and rehabilitation. As per the report says, 30% of the cost for design errors, 30% for construction errors, and 30 to 20% for material errors. Because of these errors, we are not taken care. There is a structure is going to distress before its service life. And just for the August gathering, there is a brief introduction about the speaker of the day, Dr. A. Sudhahar. Sudhahar, your video is not there?
Yeah, I'm trying to switch it on, sir. Yeah.
Okay, no issue. I have not seen your photo. Thank you. Dr. A. Sudhahar is a chartered engineer, presently a practicing civil engineering consultant offering structural, architectural, and project management consultancy services in and outside India through his consultancy for Dimensions. Welcome, Sudhahar. Formerly, he was the regional head of technical services, South and West regions, India for ACC Limited. His educational qualifications are Diploma with Honors in Civil Engineering from Christ the King Polytechnic from Coimbatore, BE Civil Engineering from Government College of Technology, Coimbatore, ME Structural Engineering from Government College of Technology, Coimbatore, PG Diploma in Health Monitoring, Repairs, Rehabilitation of Structures from Annamalai University. He is also a trained and certified by the UNESCO Chair for the Earth Institute on production of compressed and stabilized earth blocks. He is presently pursuing his excellence in management programs MBA at Indian Stock Management Qualifications. He is presently the chairman of Indian Concrete Institute Coimbatore Center, past secretary of the Association of Consulting Civil Engineers India Coimbatore Center, fellow of the Institution of Engineers India, and an active member of the allied bodies such as the Builders Association of India, Coimbatore Builders and Contractors Association, American Concrete Institute, American Society of Civil Engineers, Indian Society of Heating, Refrigeration and Air Conditioning Engineers, Indian Society of Technical Education, and also Indian Trust Arts, Culture and Heritage. He is a member of the Board of Studies and Advisory Committee of many engineering colleges and polytechnics in India, named Tamil Nadu, Karnataka, and Telangana and Kerala. He is the National Award winner for the Corporate Innovation in the year 2008 and a recipient of Outstanding Concrete Structure Award, Residential from Indian Concrete Institute, Pondicherry in the year 2018, and the Best Built Home Award from Radio Mirchi. I'm happy to share one of the awards received in 2021. He is the recipient of Prestige Vishwakarma, confirmed by the Construction Industry Development Council, Government of India for the year 2021 for the category of Best Pre-Engineer and Precast Structure. Congratulations, Dr. Sudhahar, for the achievement.
Thank you, sir.
He is presently the Chief Technical Officer for Technical Building Products Green Building Center, which supplies green building products such as fly ash, bricks, and other eco-friendly materials. He is the developer of Eco Sand, an eco-friendly alternative for the river sand derived out of the byproduct of cement industry. His research includes characterization of alternate cementitious material, fly ash, earthen buildings, etc. His areas of expertise in large span structures and pre-stressed concrete technologies. He has conducted many workshops, seminars, and conferences, and has trained a large number of masons, supervisors, technicians, students, practicing engineers, research scholars, and consultants on various topics related to the construction industry. He is presently a director of academic for Suram CV Raman Education Institution, an upcoming institution at Coimbatore. He is also the founder chair of School of Skills, a study circle for the fresh graduates and practicing engineers. He is passionate about the ancient architecture and metallurgy. He is a Rotarian Coimbatore Midtown, and he is happily married with Dr. Sridevi, who is also a business partner. She is a doctorate in structural engineering with a specialization in ferro cement and earthquake engineering. They are all blessed with a daughter and Talir studying in grade 3 of Uvabharati Public School. I am very happy and honored to welcome Sudhahar for his presentation. He is going to share his vast experience. I welcome Sudhahar to take over the session.
Yes,
Thank you once again. And also I welcome all the participants recently joined. Please interact with the speaker at the end. Any questions, please post chat box. Otherwise, at the end of the 1 hour lecture, we'll take the questions. Thank you once again, and thank you all. And please maintain the protocol of the online lectures.
Thank you so much, sir, for the elaborate introduction indeed. Above all, I feel so proud and happy to say that I am your student, and that needs no more further introduction. So both myself and Sridevi are so proud that we were your students, and we got our doctorate conferred because of you.
Introduce August gathering. Thank you for your kind words.
Thank you, sir. Yeah. So over to the topic straight away. I welcome everybody. I understand this is a mixed audience. We have engineers from Nimriti Kendra, we have students, and also we have learned technicians, very senior academicians, especially Professor Krishnamurthy who's joined us from abroad. So I'm going to keep it, I'm not going to take it too bookish, neither am I going to take it away from the core theory. So we'll keep it as a good interactive discussion. And this topic is always close to me because this is one topic which defines the class of our profession itself. Imagine you going to a mall and getting a product like anything like a shirt like from Alan Solly or a mobile phone from Samsung, anything which will cost you in thousands, and you come home, open the parcel or the packaging, and you find a defect in it. You feel terribly bad, and you start anybody for that matter, we start cursing the producer or the seller. So if this can happen with a small value item like a shirt or a pen or even a vegetable, if per se, if it is defective, then we all get agitated. But imagine the plight of the common man who puts all his hard-earned money in one building, and he makes a construction, and we give him a defective product. That is the greatest sin, I should say, being a professional. So I devised this, I designed this presentation wholly around this perspective, like why are these defects happening in a general construction? Of course, this can be extended to any level of construction. It could be extended to the construction of a dam or a bridge or any infrastructure project, but the fundamentals remain the same. So the general construction per se, like when we started interviewing, we had an interesting experiment done with a group of students who interviewed some 100 and odd people who had recently constructed their homes. it came out that 97% of the people were not satisfied with the process of the construction or the final product which they got, because they found defects in the product. And when we started interviewing the other side, the builder or the designer or the consultant, whomsoever is involved in the delivery of this product called building, they have various reasons, and almost 100% of the people accepted that you cannot make a defect-free building. But this is a very sad situation, and having so much of technology developed, so much of institutions training us, and so much of decades of previous and past experiences, we are not still confident enough in delivering a defect-free construction. So I thought we will make an attempt to highlight certain areas where we can be more vigilant in giving the delivery, so that we finally someday achieve defect-free constructions also. So let's start with this question: how good is a good building? Like people have actually lowered the yardstick. They've lowered the benchmarks, and people have started to accept that one or two defects is okay. These are all common things. So for example, shrinkage crack here and there. They say it's a thermal problem. You cannot avoid it. Few people say one or two tiles, tile grounds which are not packed properly, tile joints which are not properly packed properly. They say it's okay. It can be patched up. So it's a sad state of affair that we already have started lowering the benchmark level or the expectation level, wherein a real growing industry or a really professional industry should keep raising the bar, and we should aim for more and more perfection. So what's wrong now in a building? I don't think we have enough time to wait for responses, and it would have been very great if that was there, but given the slot 1 hour, I don't think we can stop for responses. So I'll myself give you the prompts and keep moving forward. And anybody, if you wish to intervene, you can stop me then and there and start giving your inputs also. Nothing stops you. So if you ask this question, what is wrong now? We say, at least in the construction industry, we say every construction is wrong. In some sense, it may not be totally wrong, but every construction is wrong in some sense or the other, where the owner or the end user is not always 100% happy with the product what he has got. So when we extend this question to the next one, is the construction wrong or the constructor wrong? Deep thinking will always tell you the constructor only was wrong. The construction by itself cannot go wrong unless the constructor has screwed up with the construction practice or the design or the selection of material or whatsoever. So during that survey which I mentioned, when we started interviewing the end producer, the so-called the mason or the contractor, leave aside the designers and the consultants, they always blame it on the materials. They were giving responses like, no, I did the right practice. The brick was bad. The cement was bad. It started setting so quickly. It started cracking up so much. The timber was not cured properly. I mean, it had excessive moisture, so it started warping. The tile had a bend. All these excuses started coming. But when you really ask, are the materials wrong or the men wrong? It is always the men, because you have put the wrong material. It was in our prerogative whether to choose that material or not, to use that material or not. We were not careful enough in choosing the materials, or we were not vigilant enough in inspecting the materials, and that is why probably all these defects came up. So our attitude should be in providing a kind of a solution, not answers. Unfortunately, like, not to spare me also, like most of the people in the industry, we start giving answers when we are confronted with a situation. But rather, we should all be focused on the solutions. Just to keep your moods high, because we are in the early evening, or we are just after lunch. I thought I should share you some answers which I picked up from an answer sheet, and in some way or the other, we are also giving such excuses to our clients. For example, the answer sheet to your left: expand a plus b whole power n. the guy started expanding it literally. And this is somehow there is some analogy between what we do in sites also. I'm not pointing fingers at everybody, but everybody knows, everybody attending here and even outside, they will know there is something wrong happening with the attitude of the industry itself. So we only give what we know. We really don't take an extra effort to customize the solution for the uh, end user. So these are two examples. Maybe you can laugh with the user looking at it, but yes, this sort of attitude is present. Either we are in that attitude, or sometimes we are in this attitude. This is a newspaper cutting. I took it out from a newspaper in Kerala. It is the rule book. The rule book in Kerala said once upon a time, this was the rule, that the pillion rider need not wear a helmet, or the person sitting at the back need not wear a helmet. But if you look at this picture, he has followed the rule, but he has not kept the spirit of the rule. And this also is a very unfortunate attitude what we have as constructors or designers. We go strictly by the rule book, not with uh, uh, what do you call, uh, cognizance of the overall situation at the site. We never relate it to the holistic situation at the site. So we tend to get too much into the rule and end up giving wrong results. And these are the generic examples which I am showing you, but I will slowly go into the very specific examples of the construction process itself. But I just want to set your thought process that yes, we have an attitude problem or a perspective problem. If we change that, a lot of defects can be avoided. So that was the moral of this story. So as when we come to building materials, we commonly stumble upon all these, the list which I am showing you now, the sand, the coarse aggregate, commonly known as the metal here. There is that this is also a confusion. The industry, though we have all technical terms to any material or a process, the industry works on a very colloquial kind of a language. So unless you know that colloquial language, you communicate it to the mason or the worker level, the labor level, you are not able to set the wheel in motion. So this also should be changed according to me. Like we should all be more oriented towards the right vocabulary even in specifying products. So the sand, the coarse aggregate, cement, water, bricks, steel, tiles, wood, etc., etc. Then now the all said and done, the basic construction material will fall into a list lot long, more than 10 to 15 items. So if we know by specifications like what should be the right kind of parameters for that particular item, uh, construction item to be accepted. More, what I'm trying to underline is we should all be aware of the acceptance criteria for each building material we are going to use, and all these acceptance criteria are well defined in our codes, Indian codes. We only have to sensitize ourselves to those values and stop rejecting the non-compliant materials. Only when we have a culture of rejecting the non-compliant materials do we get the vendors sensitized to it, and they start giving us the right materials. As long as you keep accepting the defective materials, the vendors will also keep supplying you the defective materials. I at least have experienced this in many of the sites where we execute. For example, aggregates, if it is very flaky or elongated, we don't take that. We don't accept that. So once or twice, we reject the supplier, we reject the load, then the supplier comes in line and he starts giving us a very good quality material. So please be sensitized to it. I am skipping all these mundane items like how to check clay in sand, all these things. I have 2-3 PPTs to skip. I mean to switch. So I'm just skipping these mundane items, but nevertheless you should be sensitized that there are very simple tests available in the site. For example, to test clay in sand. You can just use a measuring jar or a PET bottle even at site to find out whether the sand supplied to you is silty or having excessive clay, whatever. So there are very, very simple techniques at site to find out the quality of the materials supplied to you, the raw materials supplied to you. So I will not elaborate on this too much because these are all very mundane things which your textbooks have already given you. So for sand, coarse aggregate, fine aggregate, cement, all these stuff. So I will straight away go to the defects. This is a very common defect, and many people don't even realize that this is a defect. I've seen people arguing with their clients and all that this is the right kind of uh, mm, reaction for a concrete. Can anybody tell me what it is? Of course, I think it is there on the screen itself, leaching of lime. Can anybody interrupt and tell us why this is happening and whether it is good or bad?
Any one participant?
Anyone? I'm just doing this to make sure that I am online with you because I am not seeing my face or anybody's face. I'm just glaring at this PPT only.
Amrita? Bangalore. Amrita is there? Arpita? Abhilash?
Please, suppose don't take it as a Vaivavosi kind of a situation. We are just discussing and we are only going to spend the next 40-50 minutes very usefully for both of us. Yeah.
Anyone come voluntarily? No one is there, I think.
Okay, so I'll keep the ball in motion, sir. So don't worry. See, I overheard, I eavesdropped, in fact, an engineer telling to his client that, sir, this is good. This is a symbol of this, the ingredients of concreting reacting well. Only after it reacts, these white color things are coming out. Actually, he didn't realize that these white colored things, the so-called lime, has to be inside the concrete, has to be captive inside the concrete. This happens because of two reasons. Either you have increased the water cement ratio during concreting. Because of excessive water, the water has transported this lime, which is to be inside, to the periphery or to the external surface of the concrete member itself. Why this is happening? It should happen because yesterday I think you must have heard Biradar sir's lecture also. This is the primary property of cement. When it hydrates, it forms calcium silica hydrate gel and CSH gel, and it forms lime. This lime is responsible in maintaining the alkalinity of the concrete itself. Only if the concrete is, when the concrete is alkaline, the steel inside the concrete is protected because steel becomes corroded when it is in an acidic atmosphere. And according to the concrete chemistry or steel chemistry, acidic doesn't mean going for a pH below 7. Bringing the alkalinity by around 10 to 9 itself is an acidic atmosphere as far as steel and concrete is concerned. So to maintain the alkalinity of the concrete, this lime has to stay inside. If the lime has to stay inside, then you should not have water cement ratio, excessive water cement ratio or free water to bring this lime outside. Point number one. In case you have difficulty in maintaining the workability of the concrete during the pour of the concrete itself, where in that situation you'll be forced to add more water in order to achieve the workability. But dear friends, please be aware that workability need not achieved only by pouring water. You can have admixtures, you can have water and cement slurry, wherein your water cement ratio is still maintained. You use cement slurry instead of water alone, or you should have been very vigilant and careful in selecting the shape of the aggregates itself. If you have made a very sensible mix design, then also you will not encounter workability problems. So if you have done that homework and then started concreting, then the situation of adding excess water will not arise. If that didn't arise, then this situation will not arise also. But on a level of selection of materials, apart from the aggregates, you have one more important product in the concrete, which is cement. Now, I think Viradhar sir should have thrown very, very deep insights into cement chemistry. But just to recap, if you start using blended cements instead of Portland cement, ordinary Portland cements, then this leaching defect can be controlled to a great extent, because blended cement has a special ingredient called pozzolana. This pozzolana gets has an affinity towards this lime, and this pozzolana will again produce CSH gel, and thereby creating a second hydration in the system. So this will ensure better pore packing. Therefore, your concrete becomes more dense. That means your durability is increased. So please don't be satisfied, or don't think this is a pleasant situation, pleasant sight seeing this leaching coming out of concrete. Please sensitize your co-workers and laborers about it. People think this is good for concrete, but actually it is not, because alkalinity is getting lost because of the loss of lime, and also the pores are empty. Now these are pockets where moisture can attack and then thereby accelerate the corrosion process of your steel. So it's a very common defect taken very lightly. I just told you these points of pore refinements, how cement chemistry can help you in controlling the leaching problem. So I'm skipping the mundane parts. Now coming to the very important defects in a building. See, a building is subject to a lot of external harassment, I would say. By harassment by the rising dampness from the floor, attack by the nitrogen oxide, sulfur oxide, carbon dioxide, the pollutants in the atmosphere. The rain itself is like people classify the rains as acid rain only because of the pollution levels in the atmosphere. Whatever we get is more or less an acidic rain only. So these are all external loads or attacking factors on a building, against which your building has to fight and still be defect free. There are other factors such as overloading, under design, wrong execution, wrong selection of building materials, which are all captured in the building inherently. Apart from these external factors, there are also internal factors which contribute to defects in a building. I'll show you this example. This was a period when I was working for the cement company, as told in the introduction. I was working for ACC Cements, and I saw this pleasant sight of our cement being used in a site. I saw these bags with our company logo and all those things. I was so happy. I just entered the site and congratulated the owner. But I found something shocking, that they just tore a few number of bags, put it on a pile of sand, and they started mixing it. They had aggregates separately. I think you'll be able to see it in the background. Are you able to see my cursor moving?
Yes, Sudhakar, we are seeing.
Yeah, so there were aggregates. They started mixing these aggregates with this mixture of sand and cement, and they started concreting. I got shocked because the process of batching was completely ignored. When I started questioning the contractor, he said, "Sir, I know how much of sand I have procured, and I am doing batching internally. I don't worry. Overall, the ratio is good." But batching is not ensuring the overall consumption of the materials. But batching is to be done for every cubic foot or every cc of the concrete you will pour. So the uniformity proportion is gone. It was my duty to sensitize the owner that this is a very wrong construction practice. But unfortunately, this is the regional practice in many parts of South India. At least I've traveled extensively in South India than North India. But there are many pockets, many regions where this is the practice. There still we have primitive technologies to batch concrete, but this should be avoided. We should have at least use a pharma box, or at least volume batching by pans. That itself is wrong, but still in an advanced era of ready-mix concrete, we are still in the primitive stage of allowing site mix concrete and without a process of batching. Then I went upstairs. To my shock, I saw something in a pan. I think you can also see this clay mixed with water kept on the roof. I asked, "What is this for?" They said wherever we are providing joints for the electrical conduits, we put a lump of soil on top of it. And wherever we are providing hooks for the fans or the swings, we put a lump of this clay on the shuttering sheet, and then we pour concrete on top of it. I remember on one side we were advocating, if you remember your school days, college days when you studied construction materials, we had one cardinal rule of sand. It should be well graded and free from clay. Having said that, having defined that as a very cardinal principle of selection of fine aggregate, we ourselves have allowed this habit of introducing clay inside the concrete. So these are some wrong practices which are still prevalent. And finally, we end up coming up with dampness in concrete slabs, unpacked fan hook points. What happens after the formwork is removed? You still have the clay lump visible. We use a knife or a small steel rod to clean it up, and nobody cleans it with a jet of water or anything like that. So it is improperly cleaned and it is improperly sealed again with a backing concrete. Now this clay which is inside will swell after a certain amount of time, and that concrete starts spalling or cracking or whatsoever. And this is one famous photograph which I've showed at least to 200 of my fellow engineers practicing in and around my region. Everybody said things are perfect. This is the kind of consistency you have to mix concrete. They are mixing. Now sooner or later they will be leveling it. So I think this is the perfect way to concrete. In fact, colloquially, people told when I was migrating from the stage of a student to a site engineer, I remember my contractor telling me an analogy saying that concrete should look like, or you should feel concrete like curd rice. That should be the consistency. He actually meant to say the cohesiveness of the concrete. But all those are fine. But many people fail to miss out this bleeding water. If you can see the footprint, of course, I think Krishnamurthy sir is also watching this picture. He will be annoyed in seeing people working with slippers. The safety boots are not there. But leaving that topic to the safety side, if you concentrate on the material, the point where I am circling now with my cursor, you can see a footprint here, and you see a lot of free water here. This is bleeding water, which is a clear indication that there is excessive water cement ratio in your concrete. So excessive water cement ratio means low strength and low durability. This is the basic Abraham's law. So this part nobody is sensitized, and this is a major cause for defects. Defects like what? Defects like this. The classic plastic shrinkage crack is either due to too much of fines in the system, in the concrete, or due to excessive water cement ratio. As a result, the water starts evaporating too quickly, and it results in the shrinkage cracks. So if you control the water cement ratio, you almost control the cracks. So that is the moral of the story. If you can see here, like even in this side, they are at least using a batching technique. But before the cement bag reaches the mixer machine, at least 2 to 3 kg of cement is lost. Now, where is the question of your mix design? Where is the question of minimum cement content being ensured in the designed mix? So these are some of the carelessness which we do in creating the real concrete. On papers, everything looks good, but when it comes to actual execution, you can look at the coarse aggregate just haphazardly spread, and this will also be used for concreting along with the soil. So there is no proper storage system, no proper batching system. There is no proper check measures to find out whether your actual design has actually been executed. This is poor site management, poor landscape management at the site, where rainwater, or sometimes in most of the cases in cities, we are forced to pour concrete along with sewage water also. Now these are all ignored or swept under the carpet. But when it later erupts as a problem, then nobody is there to pinpoint that these were the reasons for the defects to come because everything is forgotten. Nobody has a record of what happened in the site when it was actually made, and therefore we are left clueless on how to treat the problem. So sometimes when it comes to a repair and rehabilitation project, when we go there, we find all the defects all right, but we never have a clue of how it could have happened. Now, maybe presently the source is not there, but when the construction was made, there was a pollutant or there was a source of this problem, this potential defect, which nobody noticed, and that is where we all fail. So I would appeal to the engineers community that apart from the procedures what we teach in the design or in the quality control in production, we should also be having a checklist uh, which says which clearly defines the prerequisite for each item of work which we are going to execute at site, or at least there should be a mechanism to record the scenario in which that particular item was made. Now, this also is a very accepted phenomenon nowadays. Whenever you are doing a lath work or a ferrocement work, by not providing enough cover or a proper cover for the reinforcement, then the steel reinforcement starts corroding, and you are getting all sides of this unsightly pictures and the cracks. That is one reason. The cover thickness for the reinforcement is very conveniently ignored. People use very cheap cover blocks, not properly dimensioned. Many places they still use coarse aggregates as cover blocks. This is one reason. On the other side, people don't understand corrosion very holistically. People think they have confusion between the normal rusting which happens. The steel, once you procure, it comes in a steel gray color, but when you leave it at site for 3-4 days, it turns into a orangey or a brownish color. It is due to the oxidation of the cement. It forms ferrous oxide and it forms a coating on the surface. This is not bad. You can just clean it and still use it. But corrosion is different. This is not an oxidation reaction. Corrosion is an electrochemical reaction. So when the same member, the steel, is subject to two different environments, like of different pH, one part becomes cathodic, the other part becomes anodic. So this is the simulation of a typical electrolytic cell, where you have an anode, a cathode, and an electrolyte. This electrolyte is also simulated in a concrete system where your pore water, the pore moisture acts as the electrolyte. You have one portion which is acting anodic, where you have another portion which is acting cathodic. Why this should act as anodic and cathodic at different regions? It is either because it is embedded in a concrete with different pH. One portion of the concrete might be very rich in cement. The other portion might be having a leaner mix. It may not have the same cement content. So if the proportion is varying, then in the same concrete member, one region is anodic and the other region is cathodic, and there is a potential difference which is formed, and therefore this electrochemistry comes into picture and the steel starts corroding. So this can be stopped only if the quality of concrete is maintained uniformly. It is not only okay to maintain the prismatic nature of the member, but it is also very important to maintain the material quality of the member also to be very uniform, because your steel is so sensitive to pH. So different pH in different regions will simulate an electrochemical reaction, and therefore the corrosion will become faster. This is one reason. The another reason is bimetal corrosion. If we start mixing two different grades of steel in the same system, then also this corrosion could happen. I think this is in Karnataka only. I remember this was a dental. I am not able to read the. I don't know the language. Kannada. I think it's a dental college. Am I right, sir? Are you able to read it?
Yeah. The Dharmasthala Manjunatheshwara Danta Mahavidyalaya Aspatre.
Okay, so it's a dental college where you start filling. Usually, dentistry is about filling of cavities in the teeth, but look at this wall. People were going overboard in specifying the best of cement. Even cement companies nowadays, they start advertising on the grade of cement. Even though IS has given only up to OPC 53 grade. Even for PPC, people have started specifying grades. People are saying 63 also, which means there is a race among cement producers in giving a cement of a very quick setting nature or a higher initial strength. Remember, the strength of cement doesn't always result in the strength of concrete. Strength of cement and strength of concrete need not be directly proportional. You can produce a very poor quality concrete with a very high quality cement. Very high grade cement can result in very poor grade concrete also. The mixed design itself is an art with science as its basis. So this defect happened because they used a very high grade cement for plastering. They used OPC for plastering. OPC, of course, is a rapid. It's not technically the rapid. It basically tends to set fast because of its fineness. The surface area is high, the planes is high, therefore heat of hydration is high, therefore the shrinkage potential is also high because of the fineness, and this has happened. Had they used a blended cement or a low grade cement for the plastering, which doesn't require very high strength because it's only a rendering material. The plaster is only a rendering material. It's not a structural material. So if they had used a low grade cement, they could have avoided this. So what I'm trying to say is it's only common sense in trying to choose the right material for the right application. So if we had choose the right material, then they would not have ended up in this situation. Many buildings in our neighborhood are like this only, but they were not shown as obvious as this. We immediately do the whitewashing. See, the crack filling itself is a very good product. If you come to the repair and rehabilitation sector, crack filling materials are sold like commodities now. So it's a huge market, and the market is still growing because every now and then the buildings are cracking. Even today morning, I think you would have watched the news of a building collapse in Mumbai. That was not because of overloading and all. I got the news from my friends in Mumbai. They say it is because of poor maintenance. People did not do a proper structural audit of the building because it's a very old building, and I think it's high time we start thinking about regular structural audits and health monitoring of structures also. So maybe as we do our master health checkup after 40s, when we touch 40, we are like sensitized enough in doing a master health checkup. Similarly, for buildings also, we should have some advisory which will recommend a master health checkup or a structural audit to maintain its stability and integrity. So we'll move to the next example. Now this is the same defect. This is one defect which again people have started accepting. This is called as a grazing crack. Sometimes these are not even visible to the naked eye. Once you pour some water on the surface only, you will understand this grazing crack. This is basically arising out of improper curing. People think that we have to only cure concrete the next day after the structure is done. It is wrong. You have to start curing as early as possible. When I say this, I think you should also understand what is curing. Curing is not supplying water to the concrete. Curing is prevention of escape of water from the concrete. That is curing. Say for example, you have a technology in which you can seal the entire surface. If you can laminate the entire concrete surface with a waxy layer or a plastic layer, then you need not do curing because the curing is already done. The water which you have added during the making of the product itself, during the production of concrete itself, it is still there and it is not allowed to escape. So this water is available for the complete hydration of cement. But if you start allowing it to escape into the atmosphere, either by wind or by sunlight or by the external temperature or the humidity, then this grazing crack happens. So you should start your curing as early as possible. Keep the surface moist. You should never allow the surface to become dry and then start curing. Then the purpose of curing is lost. You have already killed the surface of the concrete. So curing started as early as possible. This is probably why people are giving shades to the constructions. You would have, if you would have noticed villas around your area, small constructions around your area, which are covered with a cloth or a pandal, whatever you call, to provide shading to the building so that the rapid evaporation of water is not there. Curing is very effective. So early curing is the solution for the surface cracks or the grazing cracks, we would call. This is another classic example. 99 out of 100 buildings done for housing units have this defect. This is because of improper cover. Either you give too much of cover or you don't provide cover. There is an imbalance in the cover given, because if you start using aggregates instead of cover blocks, there is no guarantee, or there is complete guarantee that all the aggregates will not be of the same size. So somewhere it will be 18 mm, somewhere it will be 25 mm, somewhere it will be 16 mm, wherein the code recommends to use a 20 mm cover. So somewhere you have given a 10 mm cover, somewhere you have given a 25 mm cover. There is an imbalance already. And smaller covers will spall off more easily, because once the steel starts to corrode, it tends to expand. When it dilates or expands, it will push out the cover concrete. So this is there. So in the first place, why should steel start corroding fast? It is because of the quality of water itself, what we have used during the concreting. People are not sensitized to this. We are forced to use whatever water is available at site. In many sites, especially in residential construction, we make the borewell first. We never get the water tested. We are unaware whether it is a hard water, what is the TDS, whether it has got chlorides and sulfates. We don't know. The only check what we do is just gargle mouth with that water. If you are not feeling it is salty, then we assume that it is good water. And 100 out of 100, not 99 out of 100, 100 out of 100, all the clients will say that the water is good. Nobody wants to accept that their water is bad, unless it is a very brackish water. They will say, sir, it's okay, sir, it's good, you can use it. And we sometimes tend to dance to the tunes of the client. We should, as technicians, we should put our foot down and say, no, I'm not going to use this water. You better purchase good water for me, or do some treatment to this water so that the durability is ensured. But we, for the given situation, we just say okay to the client, and maybe in 3-4 years these kind of defects starts coming up. So the quality of water is of utmost importance especially when it comes to RCC construction. So quality of water, uniformity of the cover thickness, and the measurement of the cover itself, the dimension of the cover itself is going to be very important to to avoid this defect called spalling. This is also common, cracking in ferrocement, or the lath work, what you're calling. We have the reinforcement mesh inside this, and we just dab the concrete on top of it and finish it. Per se, out of all the materials we use for construction, steel is the most sensitive to heat. That is having, I think, the highest amount of thermal expansion, coefficient of thermal expansion. So what I'm trying to say is, steel tends to expand easily when heated. And if you see the lath work or the slabs are the elements which are having the maximum steel in it. The distribution of steel is maximum either in the lath work or ferrocement work, or in the RCC slabs. And incidentally, these are the elements which receive maximum of sunlight, or which is subject to having maximum conductivity of heat. Therefore, the steel inside tends to move. If you don't provide enough protection to the steel in terms of the quality of concrete, the thickness of concrete around it, then it is more liable to cracking. So the solution for this is a proper design. Use the choice of the ideal or the most optimized diameter for steel to be used, the quality of steel to be used, the water cement ratio of the concrete which will be used, and the thickness of the member itself. One more example. Now this is another good example. If you can see a horizontal crack here where my cursor is moving, This is probably the bottom of the roof slab, which they have done. Many engineers who are sensitized to informations like cover concrete and all, they use proper cover blocks. We have seen that, but even in those buildings, we observed this cracks. If you go around your town and observe residential buildings which were done some 5 years back, 7 years back, and all, almost in every building you can find out the level of the roof slab because that portion would have cracked. This is because we are not so sensitized about the side cover of the reinforcement which we have provided for the slab. Bottom cover, everybody knows we have the cover blocks in place and all, but side cover is taken for granted. Even the side cover is very, very important, as important as the bottom cover itself. So side cover, if you take care of it, to a certain extent, this can be avoided. And the other reason I told you, because the topmost slab will be exposed to maximum heat, steel will tend to expand, and therefore this will try to push the slab out of the plumb line of the wall, and therefore this crack arises. I saw one innovative practice in Kerala. If you can see this, almost all the buildings in the state of Kerala, they don't finish the roof slabs in flush with the wall lines. They have a projection. If you can see this above the lintel, they have given additional supports in order to protrude or cantilever the roof slabs outside the plumb of the wall. This is a very good practice. This will avoid that horizontal crack, because whatever expansion happens in the slab happens in the free end, and therefore nobody notices a crack. If the slab needs to expand, it expands in the cantilever portion. If it has to contract, it contracts in the cantilever portion. You would have studied the if you remember your UG syllabus, you would have studied the plate problem, the Fourier series problem, and all the heat problem, where the expansion is maximum at the edges rather than the center of a plate. So that theory is valid here. That is why probably we had it in our syllabus, but unfortunately our mathematics professors did not sensitize that application to us. But this is the reason. Once it has to expand, it can expand in the cantilever portion. So this horizontal crack at the roof slab level can be easily avoided. And I don't know by what means they were able to achieve it, but almost 99% of the buildings in Kerala are done in this fashion, and therefore they don't have this problem what we are talking about. This is a general sill level crack what you observe here. Improper sill, there are many buildings without a sill beam itself. Even if a sill beam is provided, people don't understand the purpose of a sill beam. They just end it at the edge of the opening itself. It is not going to be effective. Sill beams should have sufficient bearing in the masonry so that you will avoid the cracks at the sill level. And sill slab should be at least 3 inches thick. People go for a very nominal kind of a sill slab, which doesn't work at all. It is only provided as a ritual, not very effectively. Now this picture is a very important picture. What you have to notice. I'm not talking about the very large constructions done by organized construction companies. These are kind of constructions which you will find out day in and day out, just around us, happening everywhere. See, they have given the base supports for the props which they have used for the supporting the formwork for the concrete of the slab. Now on the day when you make all these props before the concreting and all, everything will look very good, sturdy and all. But imagine the scenario when you are actually doing the concrete at site. Now what happens? A lot of water is being used. We use water to clean the aggregates. Water is being spilled from the rooftop also where you are doing concreting. As a result, the soil becomes wet and it becomes soft. And therefore, these supports what you have given on the brick and all what you see here starts sinking. And this will result in sinking of the formwork also, which may be to a tune of 2 to 3 mm or 4 to 5 mm, which you may not even realize. But this settlement of the formwork has already caused its problems inside the concrete. There is some gap created because you already have a mesh of reinforcement inside, so it will partially prevent the aggregates from sinking down along with the formwork. Therefore, there will be a void created, and this void is always a problem. Any civil engineer with common sense will be able to accept that. And again, this is again corrosion of steel, because you have been very careless in selecting the grade of steel, or you have been very careless in maintaining the uniformity of the quality of concrete along this member. So you will have the anodic and cathodic areas, and the steel starts corroding faster. Whenever you have different mediums butting each other, as RCC column and a brick wall, we don't give enough thought to the coefficient of thermal expansion of both the materials. You don't give enough thought to the shrinkage characters of the materials, and therefore you are bound to get a crack at the junction. This can be avoided by using suitable adhesives which are available in the market now. So this, to a certain extent, will withstand the tensile force which causes the cracks. You can also do the meshing around and before you do the plaster. But all these are not rocket science. These are all simple science basics of construction. So if you are able to choose the right kind of proportions for the mortar, which renders the non-shrinkable nature of the mortar itself, then your job is done. It will not crack. But if you are using very high amount of cement, assuming that more cement gives you more strength, then you will get these cracks, because more cement also means more shrinkage. So proper assumption of the characters of the material is also of utmost importance. Now you see this example, somebody has made this corner piece of the masonry in a very haphazard manner, just because there is some vastu consideration saying that always the southwest corner of the building should be taller. This was not orchestrated. This was taken from an actual site, and this keeps happening everywhere. We are so much pious and religious about the vastu consideration, more than what is required to take care of the quality of the structure itself. So if you had to take care of that vastu elements, I'm not against the beliefs, but it has to be done very properly, not in a haphazard manner. The joints are not packed properly, as you can see in the other areas of the building. So if somebody had advised, yes, the advice probably was good as per vastu, but this is not the way to do the construction. It should have been integrally planned when the drawing was made itself. Now again, bond. We studied various bonds in our college days: English bond, Flemish bond, all those things. But the principle of bonding is gone. You can see one nice vertical joint. So once you place the slab on top of it, after the load starts getting distributed, you will definitely get a crack here, and you will be forced to think that the material is wrong, rather than assuming what went wrong during the construction itself. So this is one typical case which happens in 50% of the sites what we visit, and very unsound practices of making formwork for openings, lintels. In fact, these are some jugaad techniques what we use. Maybe these hold good in some temporary construction or low-cost construction is concerned, but for a general construction, such kind of practice should be avoided, because you have very clear-cut cases defined on when a lintel has to be designed. You might remember that 60-degree triangle what you have to draw on top of the openings. If it crosses the load transmitting member, the slab, then the design is different. If it doesn't cross, the design is different. All those criteria are there, but those are all conveniently neglected in most of the cases. And I've already assumed, I've assumed enough or observed enough that most of the buildings, at least in residential sector, the design for the lintel and sunshade is almost standard. Nobody designs it. It is only a copy paste which is happening, which is also wrong. The lintel itself has a design procedure. It is dependent on how much of load the spandrel above the lintel is going to transmit. what is the kind of slab above it, whether it's a two-way slab, one-way slab, what is its span, what is the amount of load which will get transmitted. All those things are to be considered before you even design the lintel. But I find you can also find, you go to any building, all the lintel sections will be the same. We never question how it could be same. Whether the load transmitted by all the walls is going to be same, it is not the same, because the spans of the slabs are different. The loading patterns are different. So the loading on the lintel also has to be different. Therefore, the design of lintel also has to be different. But we don't do that. So these are some lethargic mistakes which we do. This is another common mistake where somebody has overemphasized on curing. We cure and cure, so that we form algae moss layer on the walls, and it is not very effectively cleaned also before the plastering is done. Therefore, we are bound to get cracks or spalling or delamination of the plaster itself. So these kind of mistakes are also to be avoided. If you look at the column here, there is some honeycombing. People will say, no, nothing to worry, sir. We are anyhow going to plaster it. But will your plaster enter all these voids what we are seeing here? No, plastering is only a superficial coating you have given, which means you are locking a pocket of air inside, which can expand when the temperature goes up, which can provide space for moisture to be present there whenever you have a rain splashing or events of when you yourself cure, then it will attract moisture inside. So this moisture stays inside, attacks your steel, and initiates the corrosion process. So all these kind of defects should be avoided in the stage of the making itself. So either your mix design should be so robust that even if you are a little bit careless about the vibration, the surface should be smooth. So the powder content of the mix itself should be very well defined and well designed. Or if you have chosen a very normal mix, then you should ensure that the construction practice is very good. Use the right kind of vibrator. Use the vibrator for the right amount of time. Just don't do the vibration very superficially. Use the proper kind of formwork. Do proper oiling on the formwork. So these are all some rudiments. These are all some basic things which has to be followed. But it is not always presented to you in the form of a checklist. As an execution engineer, it is your duty to ensure that each and every small step is being religiously followed. Now, this is it is a very common kind of a formwork which you use for residential construction. At least in the suburban areas, people use it. In the urban areas, we have already resorted to steel sheets. But whenever you are using timber formworks, these gaps are most oftenly attended with kind of organic materials. People are using plantain leaves, clay, paper, all these things which are organic in nature, and the kind of chemicals which it will release when it comes in contact with moisture will also affect the performance of your concrete members. So you can see in this picture some paper stuff which was used to fill a gap in the formwork. Before plastic, this will not be removed very effectively. It is carelessly pulled out. A portion of the paper gets stuck inside the concrete, and it is plastered along with it. This is probably a teacup which was used for filling the gap. And there are portions of the reinforcement from columns or any element left exposed to the atmosphere. This is again an ideal situation for corrosion to set in, because the steel bar is partially inside a highly alkaline medium, concrete, and partially outside. It is exposed to the humidity, and therefore the corrosion starts very early. This is a mistake from the drawing desk, or from a desk like a from the desk of a stupid engineer like me. We only design the steel for the moment and shear force, and we are satisfied once the AST requirement is satisfied. No, we should also think of feasibility of concreting. If such a section is designed and executed, where is the gap for the concrete to fill in? So due thought process has to be given in terms of the execution of the design itself. So rather, I would have gone for bigger diameter bars, fewer in number, so that I ensure gaps between each longitudinal bar so that I can pour some concrete inside. So if such kind of thoughtless designs are being executed, we are bound to get more and more um, defective buildings only. So I will like to once again recap few of the important defects. One is the major defect is cracks. So cracks can be avoided by choosing the right materials if it is not a structural crack. Structural cracks happen either because of a poor design or an overload or poor estimation of the subsoil characters. If the soil starts to settle, then due to consolidation or it could be an immediate settlement also, then also the cracks will appear. So that's a different topic altogether. But what is there immediately in our hands to control? Yes, the construction practice is there, assuming that the design is good. If you assume that the design is good, or whenever the design is good, then the cracks or the defects appear only due to wrong materials or the construction practices. See here they are using only a very thin rod to do the compaction. This is not decades old technique, not even 1 decade old. It's at least 3-4 decades old. Now we are in the age of very effective vibrators. Handheld vibrators are available at a very cheap cost. You can any builder or any house builder can afford to buy one vibrator for the entire house. It's costing not more than 15 to 20,000 rupees. But that will ensure proper compaction, and therefore it will give you a very very good or a defect-free RC element. So compaction is one. Whenever you are mixing material, two different materials together, then you will have to take care of the thermal expansion and shrinkage characters, proper curing techniques. The time in which you start the curing is very important. I told you, if you do a curing after the surface is dried out, it is as good as not curing the surface only. So curing is not applying water to the concrete, but it is preventing the moisture from escaping out of the concrete. Use proper cleaning techniques. Spacing, yes. See, you can see a good construction practice here where he uses a proper equipment to do the grooves, to make the grooves for the electrical conduits. Many places we use chisels. We chisel out unwanted portion and thereby ending up in putting different materials. We put a very rich mortar in repacking it again, and rich mortars will shrink, and therefore we will get cracks in walls. Some common things we do, like if you have designed a chajja, we try to innovate. We make jugaad wardrobes out of it, but the sunshade would not have been designed for such a strong dead load. Therefore, it is subject to cracking. So the change of utility also has to be very carefully done with the consultation of the designer. Again, converting a balcony into a toilet. Toilets are designed with sufficient surcharge loads, the load of the filling material, all those things. But balconies are not designed so. If you're trying to convert a balcony into a toilet, then due consideration should be given in strengthening the slab, or at least checking the reinforcement provided for the slab and ensure that it will carry the new loads. So change of utility is one thing. Unplanned plumbing systems, like if you are converting an Indian type closet into a European type closet, the traps should be planned so properly. You cannot just like that make a core cutting through a structural member and do, but people do and still survive with it because probably the robustness of the structure is so good. But it will someday or the other start giving you headaches. It will give you problems. Taking electrical conduits through chiseled beams. If you have not planned it properly during the execution itself, you grade the beam and then you chisel off the cover concrete and then you try to give the conduits. This is also going to attract problems for you because you are already eaten the cover concrete. So these are some fundamental mistakes people tend to do, and we as engineers also become party to it because of vastu considerations, functional considerations. If the slab is not designed for a line load, as you are seeing in this case, the beam would have been designed for this line load of the wall, but the slab need not be designed for this line load. But very confidently, we also break open the wall and move it outside or create a new one on the slab. These are some wrong practices which we encourage, and I think we should put a big full stop for all such nonsense to happen. So this is an example of the unscientific cover blocks what we use. We have here they have used aggregates itself as the cover blocks. You can see each aggregate is of different size, and you can see this clay being put on the fan hook what they have provided. There are very modern hooks available, ready-made hooks available with proper steel casing. You could have just avoided. These are not, and those are not very costly even. They are very much affordable for the common house builder. But still we resort to jugaad systems. So the cover block quality is also very important. People also resort to very cheap cover blocks, non-engineered cover blocks, and therefore they will also attract problems. This is one good story or good graph to observe. This was derived out of a research paper where they have already they actually conducted measurements and observations in at least 300 buildings to understand that if your cover goes down by 2 mm, see if you can see the cursor moving. If your design cover is actually 20 mm, but actually your cover executed at site is 18 mm. If you can have a 2 mm cover deficit, it can result in a 10-year loss in the expected life of the slab with respect to carbonation effect alone. So if your slab is deteriorating by carbonation alone, a 2 mm cover deficit means a 10-year loss in life. See how important such a small thing is in deciding the quality of the building. So I think for the given time frame, I am closing with this. If at all you have questions, I can answer. I have two other PPTs in standby. I will open them as and when it is required, or if I have to give you an explanation.
Dr. Sudhahar has presented based on his experience, what are the common mistakes we will do at site. See, it has been observed by many engineers, because all the engineers who are all participated today from the district level, and where the construction industry is unorganized. It is not going very systematic way. And you can see all these problems. Now you can realize how these problems will encounter the lifespan of the structure and quality of the buildings also. See, we have to take care of all, because there is no supervisor is there, many sites. Even there is no quality reports are generated from the sites also. Because of these things, when there is no quality control, there is no person to generate material, what quality we are receiving. You rightly mentioned, the selection of material is very important, and also construction techniques. See, many of the buildings what Sudhahar has presented, you can see very sorry state of affairs. These things you can observe in tier 3 or tier 4 places only, because many of the tier 1 places are organized and MNC companies are there. The quality project management consultants are there. Therefore, I request all the Nirmiti Kendra engineers to take care, because the quality of construction is very important to improve the lifespan of the structure. So engineer has rightly mentioned 2 mm cover thickness is going to reduce 10 years lifespan. See, the lifespan of the structure as per evaluation is 60 years. The many structures are collapsing before that. So now I request the audience, if any questions are there. I think, hello, I'm audible?
Yes, sir, you are audible.
Yeah, I request the participants, any questions are there?
So could I ask a doubt?
Yeah, please go ahead.
Yes.
Please go. Please introduce yourself, sir.
Yeah, so I'm Hormus. I'm a project management contractor based in Cochin, Kerala.
All right, sir.
Yeah, I've done that. I've also attended a course of CNTI, CACM course, the Advanced Construction Management course.
Okay.
So my doubt is, we of late, in Kerala, we have a lot of houses. Well, earlier, we used to put a truss or a tile roof above a concrete roof. Nowadays, we have a lot of structures with exposed concrete roofs.
Yeah.
So one practical problem which we face is, after casting the slab, By 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 compulsion, generally what happens is most of us we do waterproof concreting on the slab before the plastering. So
are you talking about a waterproof concreting, or you do a
no,
waterproofing membrane?
We might do a proper waterproofing concrete, but above that, the general practice is we use some cementitious waterproofing compound above the slab, and then concrete or screed plaster it afterwards. So the problem which we face is after 6 to 7 or 8 months, there is a bonding issue between the slab concrete and the plastering which we have done because of the waterproofing compound which we have applied in between.
Yes, sir.
So what is your recommendation for a slab, how to be finished? Would you recommend waterproofing in between the plastering and the RCC slab? That's my question.
Yeah. Sir, if I have to talk like someone who has jumped from heaven, I would say waterproofing itself is not required if you have done your concreting very properly. If your base design was good and your execution is good, the slabs actually don't require waterproofing. Because concrete itself is supposed to be waterproof. It has to be stone-like. But given the kind of workmanship which we have, we are forced to use the local labor only. So a kind of a waterproofing system on the slab has almost become compulsory now.
Yes.
So if you are going to do such a thing, then you have to ensure that you have applied suitable bonding agents before you put the next layer. There are good bonding agents available. I will not endorse one or two companies. There are like almost all the companies have got very good bonding agents, which has to be applied immediately after the waterproofing membrane is done, because waterproofing membrane is mostly epoxy based, which adheres well to the concrete mother slab.
Yes.
But the system which you are going to put over the waterproofing membrane delaminates. Because no waterproofing guy is going to tell you, if you use my system, you have to use one more system in order to put something on top of it, because then you will assume that the waterproofing is costly. So nobody recommends you that. He stops with this waterproofing. He will store water, give you a quality check. He says that nothing is leaking. Now your waterproofing is good. But if you put another bonding agent on top of it before you put this screed, then this problem is stopped. Sir.
Okay. Thank you, sir.
So,
in case we here in Kochi and all, we do proper wave batching at sites, and we don't have a problem with concreting. In such a case, is it necessary? Absolutely. Or can we do the waterproofing finally on top? Some exposed type of waterproofing, silica.
Absolutely.
After the rendering.
Systems are there. Systems are there. Nano systems are there. You put your weathering course tiles and all. Then you put there are breathable waterproofing coats also available, which will not hinder the breathable nature of the terracotta tile what you put on top, but still it will make it waterproof. It will make it hydrophobic. If you pour some water on top of it, it tends to roll as if it is on a lotus leaf.
And so I'm not mentioning brickbat cover or anything. I'm just mentioning applying screed plastering right over the slab and then using a external waterproof coat.
Yes, possible, and a lot of systems are available. I myself have used not in Ernakulam exactly. I've used something in Irnyalakura. It is there. And it works. I've observed it at least for the last 12 years. It is working.
Yes, sir. Because these waterproofing recommendations are creating a lot of issues for exposed slabs.
Yes. And the waterproofing guys are not very honest enough in telling that my surface is going to be smooth. You have to use another system in order to adhere to it properly.
Thank you, sir.
Yes.
Arpita, you have any question? Arpita. She has posted the impact of slab cover versus lifespan chart, whether it is available, where it code. You have shown some chart actually.
Yeah, I think it was derived from the journal. It was derived from a journal, so I have already answered.
Madam has answered. Okay, you are answered. Okay, okay. Just I
Yeah,
saw. Not from, it is from the Indian Cement Review Journal.
Review Journal.
Yeah.
I think it was from September 2018.
Okay, okay.
I have that scanned extract, sir. I can send it across to you. You can share it to
Okay,
the
no issue, no
participants.
Any other questions from the participants?
Hello, sir.
Please
Yes, ma'am.
introduce. Please introduce.
Sir, my name is Elizabeth. I am a CMTI student, sir. I have a doubt, sir.
Okay, ma'am. Please proceed.
Sir, you said that our steel reinforcement should not be exposed to environment, no, sir?
Yes. Yes.
During our construction thing and all, up to like if suppose I'm constructing my house for just for one floor, for future after for constructing second floor thing and all, we'll leave the reinforcement from the column as it is, sir.
Yes.
Yeah, even though we know that it will our reinforcement will be getting corroded, in spite of knowing that also we are leaving. Why that, sir? Is there any method to protect it, or?
Yeah. Ideally, if you are going to do for the future construction, like later, maybe after 3 months, 4 months and all,
Yes.
if you can afford, you can make a dummy column. You can provide a brick column around the reinforcement. Keep it non-exposed.
Okay.
That is one way. People use a very low-grade concrete or a lean mixture of concrete, but that again is against the law. We say we just now saw that if you are exposing reinforcement to a very alkaline medium and a less alkaline medium, then also corrosion will start.
Yes, sir.
So there are epoxy paints available which prevents the reinforcement from getting in contact with the moisture of the atmosphere. So you can put an epoxy paint.
Okay.
You can make a dummy column, or option 3, the least possible thing you can do is paint the reinforcement with a nice rich lime.
Okay.
Because lime is very alkaline. Okay. But which you have to inspect often, because due to weathering action, if the lime falls off, again it gets exposed. So you can provide a proper lime wash.
Okay.
That is the cheapest. Next cheapest would be providing an epoxy paint.
Okay.
Third one will be to provide a dummy column itself, and then to break it open when you are going to do the actual construction later.
Okay, sir.
Yes.
Okay, thank you, sir.
Any other questions from the participants? I think no more questions from the participants. I think Sudhakar has given clear picture about what are the various common defects we are going to do at the site. So those, Professor, do you have any questions, sir? Professor?
No, I just want to say I enjoyed the whole talk, learned a few things, and was
Yes, sir.
comparing the sad state of Indian farm work,
Yes, sir.
farm work in Singapore, on whose committee I happen to be a member. But it cannot be helped. I'm glad that Sudhahar has pointed out how we could improve it.
Yes.
Leakage and settling of the foundations are the two biggest problems in farm work. So leakage can be avoided by some of his suggestions. Settling, I think Indian soils are much better than what we get in Singapore. So that may not be a problem. Anyway, I am glad I attended this. Congratulations.
Thank you, sir.
Thank you.
I think we will have a small, Sudhakar, you have free now?
Yes, sir. Yes, sir. I can.
Yeah. Now I request the participants, if there is no question, please fill up your forms and log out from this webinar. We have small meeting with the professor. I think you fill up the Google form shared by Mr. Sanat Kumar, and please log out.
Thank you, sir.
Yeah.
I think we can you, me, and professor can log in through a WhatsApp con call, sir. I'll just initiate a con call.
Which one? One more?
In the WhatsApp.
Sanat Kumar, Mr. Sanat Kumar. Sanat is there?
Sanat is not online, sir.
Okay.
Sir, I am there. 1 minute, sir.
Just for 10 minutes, we have some small discussion. Is it okay for you?
Sir, 1 second.
We'll share again. Okay.
Yes,
professor, sir, I think we can log out and we can connect over WhatsApp, sir,
No,
on a
1
video
minute,
call.
sir. 1 minute. 1 minute. I will just disconnect the recording and all.
Okay.
Just wait for 2 minutes, sir.
Okay.